Now we are going to see how a queue will be operating. So generally queue works on the basis of first in first out, which is nothing but whichever the element which we are inserting inside the queue on the first is the one which we can be able to pop first. That's what is first in first out. So wherein whenever we were talking about the stack, so stack generally works on the basis of last in first out, but whenever we were talking about a queue, it works on the basis of first in first out. And the major operations that the queue will be able to perform is one is dequeue and the other is enqueue. In dequeue, we will be having two different conditions through which each and every time the dequeue operation will be performing. Take for example, there is a queue in actually the queue is empty and we were about to make some pop operation in it in an empty queue. So that should not happen. Uh, and in the same way, in the queue, if the size is only two, it is of two size only. So all the two is also filled, and we were about to add one more element inside the queue. So that is also an impossible case. So we have to write these two functions of the queue within the dequeue and enqueue. So this we need to take into consideration. And take for example, I have two elements inside the queue in RQ and I'm about to make some DQ operation in it, yeah, we can be able to do that. So we can be able to remove an element from the queue, which is of the first element has to be removed because queue works on the basis of first in first out. So the first element can be popped up. Likewise, if the queue is empty, so it is very much easier for us to add an element inside the queue. So that will be possible. So we have to write these two functions like in queue. If the queue is empty, we cannot be able to put an element in from the queue. So that's why we have to terminate the program. Wherein in enqueue, if the queue is full, and in that case, its size is 2, and if we were about to add one more element inside the queue, and that is also an impossible case. So we have to write these two conditions inside the queue. And let's directly see the code and understand this part. Here we have a normal main program which consisting of public static void main. Here I'm going to create a queue. So take for example my queue consisting of an element. So I'm going to create an object over here for queue. So this queue class we need to create separately. Let's allocate a size of 5 for this queue. And we have this object has been created for this particular class queue. So what I'm going to do is I'm going to create a class here. Class queue. Here I have created a class and for this class I have created an object queue. I will make as we have discussed. So we will be having two different operations. One is enqueue and the other is dequeue. Enqueue and we can make one more operation like dequeue. Make sure we are going to access this queue with the help of an object. So this is queue is the object that we have created. So I'm going to access it with the help of this. As I have an end queue, so here I'm going to, whenever I'm going to add a new element, I have to insert a value inside the queue. So such that 1 is the new element that I'm going to add inside this queue. This queue size is 5. So this is what is the context for this. And let's write down some of the other elements so such that it will be easier for us to understand. Enqueue of 2. So I'm going to add second element inside the queue and one more element I will add inside this queue. 3. So such that whenever we are going to see the front element inside the queue. So Take for example, if I have a queue, in that queue, if I'm about to pop the front element, I need to give like queue dot peak, which generally gets the first element. I'll give a sysout statement for this. This is a front element, so I'll mention this plus queue dot peak. Yeah. Again, we are going to make a dequeue operation, so such that second element will be becoming the first element, because in dequeue one element in the front has to be removed and the second element will be becoming the first and foremost element. So that's what the dequeue operation will be actually doing. And let's check the first element again. Uh, and let's have one more other operation like queue dot size. So which generally gives the size of the queue. So I'll just print the size of queue can be get in with the help of queue dot size. And we will make one more dequeue operation, q dot dequeue and q dot dequeue. So whenever we will be actually practically implementing all these things, building a queue class will be becoming very much easier. So that's why I'm just concentrating on this part first. One more thing, if sometimes the queue will be actually empty. So I'm going to get this function. So if queue is empty in the sense, uh, my system should have to print it is an empty queue. If not, so it has to print some values like queue is full, queue is not empty. So that will be fine. Queue is not empty. Otherwise, it is not needed because the operations will be generally taking place. Sorry, queue is not empty. Let's jump into the queue class queue, so such that all these errors will be getting place, so getting in its place, so such that I have a class queue. Here I am going to create a constructor, so which consisting of queue of size integer, because I have an argument that has to be passed inside this, so which is a size, so I'm going to define it. Within this I have an array, so that array should be of new int of size. So the size should, of this particular queue should be defined. And then I'll be having a capacity of the queue. So which I will be giving the size. I have the front element, which is nothing but an array. So array means we will be having the first zeroth element will be the first element. I will be defining zeroth element as the front element. I have a rear element. Rear in the sense, rear means last one. So we can be able to define it as -1, because if any of the element, so which is at the last, so we will be generally defining it as rear, because it can be customized after a new element can be added inside the queue. So that has to be increased. So how we can be able to make this operation with the help of count, we can be able to do that. So I'm at first, the count should be 0, and each and every time a new element has to be added, the count numbers should be increased from this. So we will be adding a count, and we have to add all these variables outside as well. We can, as it is a constructor, we have to declare all the variables inside this as private. So what are all the values that we have to add in the sense? One is array, and we will be having a front, and we have a rear, and we have a capacity, and we will be having a count. So all these values has to be declared as private, and then and then we have to create a constructor, and we have to pass all these elements inside this constructor. As we have already discussed, we have two different types of operations in this queue. One is enqueue, one and the other is dequeue. So dequeue in the sense, if any of the queue's elements are empty, we are going to declare that we can't be able to pop any elements as the queue is empty. So we are just returning, and the system has to be written like system dot exit. So let's implement this one. So public integer dequeue, as this is a dequeue, so we don't want to initialize the size for it because we are going to remove an element. By default, the first element has to be removed, so no parameters or argument has to be declared over here. Wherein in enqueue, take for example, in enqueue in the sense public int enqueue, yeah, sorry, void enqueue, here an element has to be added. Here, I'll declare it as an item. So a new element has to be added inside this queue. If a queue is full, so I will add this particular thing in enqueue. And what about dequeue? If it is empty, this operation has to be completed. If it is empty, as we have already discussed, in dequeue, if any of the element is not present inside the queue, we have to print underflow or something like queue should not, queue is empty, queue empty, not possible, pop up not possible, pop not possible. Yeah, and we have to exit from the system. So system dot exit of -1, a constant. We can be able to give any constant inside this. And the second condition that we have to do is a normal dequeue operation. For that, I'm going to declare an element x. So which is nothing but the front element, because the front element has to be removed, which is a zero, right? So zero, we are not going to declare it as simply zero. It's the front element. Uh, Again, I'm going to declare that an element I'm going to remove from this. So I will declare like removing the particular element. The name of that element will be x. So x I have declared it. So I have to mention this x over here. And that's how we can be able to remove this element from the queue. X, this particular element which is present on the first, will be removed from the queue. We will be having front, because as the front has been removed, so the front has to be updated. So front has to be incremented, and then a modulo operation has to be done with respect to its capacity. Yeah. So as of now, in dequeue, we have a size 5. Take for example, I have 5 elements inside dequeue. So such that I have removed an element here, then the size has to be shrink to 4, right? If the size is 5 and it has to be, one has to be removed, means it should be 4, right? So we can write like count minus minus. So again, we have to return the element, because the return type that we have given here is int. So that's why we have to return the element over here. It is x because we have declared it as x. So that x, but a particular element has to be removed from the queue. Simple. So this is what we will be calling it as a dequeue. And talking about enqueue, here, if it is full in the sense, we will be declaring, yeah, if it is empty, we will be declaring queue is empty, so pop-up is not possible. If it is full in the sense, we have to keep queue is full. So pushing an element, push not possible, right? So just ulta, this particular thing. Same. So exit operation has to be done. -1. Here, same. Again, if a remove operation has to be done, so we will be giving, so such that if an element has to be inserted also, we will be giving inserting a new element. So here we have declared some variable over here. So let's take any other variable like integer y, something like that. So inserting an element y. Here the rear element in dequeue front has to be updated by increasing its array size. So 0 has to be moved to 1. Likewise, here rear has to be updated. So rear is equal to rear plus 1 modulo capacity. So that has also be increased. So such that we have to make a modulo operation of capacity. Capacity is nothing but the size, the maximum size of the queue will be declared as a capacity over here. And we will be having array of rear should be the element. Why? Because in that particular place only, so this particular element has to be added inside the array. Uh, and we will be adding the newcomer element, the newcomer into our new queue, which means an array. So we will be declaring it. As we already know, so whenever we were removing an element, we will be using count minus minus. And here, if we were about to add an element with the help of enqueue, we have to increase the count. So count plus plus. This is simply the enqueue operation. As we have already discussed, if the queue is full, push operation should not be possible and the program should terminate. If not, if not, this particular condition will be getting executed because here only we will be having an exit condition. So in enqueue, if it is full in the sense, this the program should terminate. If not, so this will be getting executed. So this is what we will be doing. And we will be having, as we have completed dequeue and enqueue, we have one more two operations. One is peak operation, so which will actually fetch the topmost element. So that's what we will be making it as a peak operation. So this will return an element because as this is the first element, so it has to return some value, right? So that's why we will be giving public end of peak. We will be having one more element, so which is size. So public integer of size, so which will return the size of the actual queue. And we will be having one more function, which is nothing but is empty. Public boolean, because if it is empty or not, generally we will be checking with the help of boolean value. If it is true, yes, the queue is empty. If it's not true, no, the queue is not empty. So over here we will be declaring this as well. And as we have is empty, we will be having one more function full. So what we will be giving in the sense public boolean is full, which actually gives if the queue is full, then that particular pop operation has not to be done. For this, we are writing this function. Let's complete all these values. So if it is peak, so peak in the sense we have to declare the first and foremost element of the queue. So for this, let's write if sometimes queue is empty, right? So in this case also, this empty. So in this case, what we need to do in the sense, same underflow. As it is an underflow, we will declare like queue empty peak. So because we are about to find some first element. As the queue is empty, there is no first element, peak not possible. And we have to throw system.exit. System.exit in the sense some other abrupt or unwanted input has been given. Take for example, sometimes if the queue is empty and we were about to make any peak operations, it's an abrupt change. So that should not be possible as per our use case that has been given. So we have to make sure that all the test cases has to be covered with this. So that's why I'm just giving system.exit. Here I'm going to return this value. Return array of friend, which states that first element, so array of 0 has to be written, because we have already declared like array of 0 is the friend value. So we will be changing the 0 to 1 2, so all the elements have, it's dynamic, right? So that's why we should not write 0 as it is, we should not hard code it. So for that we will be converting it into friend and will be writing that. What is the size generally? So we will be returning the count of the array. What what if the queue is empty? So what should be the criteria in this case? In the sense, only if the size is zero, size of the queue is zero, in the sense it is empty. Then what about if the queue is full? So capacity, right? So if the size is zero, it is empty. If the size is equal to the capacity that has been given, then the queue is full, obviously. So we have to return size is equal, if return the value if it is true or not. So that's it. We can run this program and try to execute. Let's We have got into some errors, so which states that variable size should has to be defined. Yeah, we have already declared the size over here. Then what's the issue? Yes. So here, as we have the size, it has to be declared as a function. So then the error will be rectified. Let's do that. Yeah. So let's run this code. Okay. So over here, let's check with actual output. As our queue size is 5, and we are going to make the enqueue operation. So such that all the elements has to be inserted inside the queue. That's why it is showing inserting 1, inserting 2, inserting 3. Front element has been given. Again, as the dequeue operation is present, so the front element has to be inserted again. Let's check that. So in dequeue, the element has to be removed. So if the dequeue operation is present, so it should obviously remove an element. Yes. So the size is 5. The element, all these elements are made into dequeue, so such that no more elements are present inside the queue. That's why it could not be able to remove, because see, we have added all the three elements and we are about to make some dequeue operation. So the queue is generally empty and we were about to make some operations in it. So as the queue is empty, so it will be returning -1 from this. So that's the reason why the code has been completed with exit code -1, because we have given exit code as -1 here. Status is equal to -1. So that's why it's just returning as, because the queue is empty. Yeah, this is in short of the queue operation that we will be making. We will be having two different operations in that. One is enqueue and the other is dequeue. In the case of enqueue, we are going to add some element inside the queue. So such that if an element if the element is full inside the queue and we are not supposed to add one more element inside the queue, that's enqueue. And in dequeue, if the queue is already empty and we were about to remove some elements from the queue, so that is also not possible. So we have to return system.exit of -1 here. So all these operations will be taking place inside the queue. That's it. Thank you. One small context is such that, take for example, I have a queue. So in this queue, peak will generally give the first element. So it will generally get the first element of this. So that's why uh, only peak can be able to pop the first and foremost element. And front should be generally this one, and which means the first and foremost element of the array, and the rear should be the last element. So this actually varies, which is depending upon the size of the queue. So in this case, take for example, if it is 3 in the sense, the rear will be changing in accordance with the size of the queue.